Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 287. Please turn to page number 287, the very first problem in the second column, number 135. Today's our lesson number 188, page 287, problem number 135. Let's take a look at it, see what they have to say. It says, a school administrator will assign each student in a group of n students to one of the m classroom. So we have to assign n number of students. We are told that we have m number of classrooms. We are further told that the number of classrooms that we have in the school is somewhere between 3 and 13. In other words, m is either, let's make a note here, m is equal to either a 4 or a 5 or a 6 or 7 or 8 or 9, 10, 11 or 12. M cannot be 13 because it does not say equal to. It says between 3 and 13, so it can be anywhere from 4 to 12. That's the number of classrooms we have in the school. Question simply is, the question that they're asking here is, if the n number of students, if m is between 3 and 13 and n is more than 13, obviously number of students would have to be more than the classroom, but that was a silly thing to say. Is it possible to assign each of the n students to one of the m classrooms so that each classroom has the same number of students assigned to it? This is how the problem is written. What they're basically asking is this: will we have the same number of students in each classroom? In other words, do we have situations where the total number of students that we have happens to be evenly divisible by the total number of classrooms that we have? In other words, is m evenly divisible by n? Or is m over n an integer? That's all they're looking for. This is the question. That is the bottom line. That's what we want to get at. If we can divide m by n, when we divide m, then it should be n over m, not m over n. N is the number of students, m is the classroom. M is the classroom, n is the students. So when we divide the number of students by a given number of classroom, will we end up with a whole number? That's all we're looking for. It has to be an integer. Now typically, if you have watched my other videos on data sufficiency, we always start out like this. We always start out with A, D, B, C, E. We write this down first and then we start our work A, D, B, C, E. That's because 9 out of 10 times we do actually start with the first statement, by the mere fact that, I should say only by the mere fact, but only or by the mere fact that it is number 1. So we typically do first statement by the mere fact that it's number 1, it's statement number 1. But there is no law that says that you have to analyze statement number 1. We just do it because it happens to be the first one. However, every once in a while I come across situations where I look at the first statement and I say to myself, I hate it. I don't like it. It's too difficult. It's too complicated. I don't want to look at it first. In that case, what we would like to do is start with the second statement first. And after I started with the one statement that I find easier, and if the second statement happens to be the easier, you start out with that one, then you analyze that thing. Even in the worst case scenario, even if you still have trouble with the first statement that you skipped, if you still have trouble with it, at least in the worst case scenario, we will have narrowed down our R's to 50-50. So I want to start here with the second statement only because I find it much easier to deal with in this problem than the first statement. Now if you were to do that, you have to remember immediately to go back and fix this. It is no longer A, D, B, C, E. It is going to be B, D, A, C, E. Alright, let's begin with the second statement. Alright, here, second statement is already written down. Now I have written down second statement in words. In the book it says, it is possible to assign each of the 13 times n students to one of the m classrooms so that each classroom has the same number of students assigned to it. What they're basically saying is this. What they're saying here is that if we had 13 times as many students, however many students they have in a school, we do not know, we just know it's n. If we had a situation where if we did have 13 times as many students, then we are told that we would be able to divide. In that case, we would be able to divide the number of students evenly into the number of classrooms. Based on that fact, are we able to answer this question? Let's find out, shall we? Let's find out. Okay, see what happens. So we know now that 13 times n is divisible by m. 13 times n is divisible by n. This is an integer. We know that for a fact because that's what they tell us. But we also know, but we also know for a fact. We also know with certainty that 13 is not divisible by m. 13 is not divisible by m. We know that for a fact. How do we know that for a fact? How would we know that for a fact? Because m happens to be, because it is between 3 and 13, m happens to be 4 or a 5 or a 6 or a 7 or a 8 or a 9 or a 10 or a 11 or a 12. As you can see, we cannot divide 13 into any of these integers. 13 is not divisible by 4, 13 is not divisible by 5 or a 6 or a 7 or 11 or a 12. 13 does not divide into any of these numbers. And yet we know that this is an integer. What does it tell us? Since we cannot divide 13 by m, since we cannot divide 13 by m, that tells us that n would have to be divisible. I can't spell divisible. Would have to be divisible by n. And that's all it is. That's all. That's the end of the logic. It's very simple, very straightforward. Here's what's going on. What can we do? I'm going to write it here. I'm going to erase this part here. Watch what happens here. Here is the quantity that we have. 13 times n divided by m. There are two ways we can write this. Either, where can I put this thing? I need the room. I need a lot of room. Well, we already got this thing. We know for a fact that 13 is not divisible by m. 13 cannot be divided by 2 or 3 or a 4 or a 5 or a 7, 8, 9, 10, 11 or 12. 13 will not be able to divide it by any of those things. It is not divisible by m. Here's what's going on. 13 over m can be written in two ways. Either it can be written as either 13 over m would have to be an integer, and then n is another integer, and integer times integer would be an integer, or 13 would have to be by itself, and n over m would have to be an integer. Because this is an integer. We know that this is an integer. We are told that. We are told that if we had 13 times as many students, and if we were to divide that total number by m, then we would get an integer. It is divisible. And if this quantity is an integer, there are only two ways we can get an integer out of it. Either 13 over m would have to be an integer, and the times n, which is an integer, would give us an integer, or 13 would stay by itself as an integer, and n over m would have to be an integer. But we already established that this is not possible. This is not possible. This is not possible. 13 is not divisible by m. Therefore, n would have to be divisible by m. It's a tricky question. It's a tricky question. That's why data sufficiency questions are more fun. They are more fun because these are not your traditional multiple choice questions where a question is put in front of us and we simply have to solve it. Data sufficiency questions sometimes actually really do make you think. And that's all it is. So simple logical thinking will does lead us to a deduction. We are able to deduce that n, whatever the hell it is, must be evenly divisible by m, because 13 cannot be divided by m. That's all. So the second statement does the job beautifully. And since the second statement works by itself, now we know that the answer cannot be A, C, or E. It would have to be either B or a D. Now let's look at the first statement, shall we? Let's look at the first statement. I need a room, so I'm going to have to erase everything. We're done with this thing. I'm going to give you a couple of seconds in case if I was blocking the blackboard. I forgot my tea. This is what I typically do. I have a sip of my tea. Okay. Let's look at the first statement. In the first statement they tell us, let's see, what do they tell us in the first statement? They tell us that if the population, in other words the number of students, if the population happens to be 3 times the actual number, then 3n over m is an integer. This is the same as the second scenario, except second scenario was easier to deal with because it involved 13 and the classrooms were only going from 4 to 12. So that's why it was I found it easier. This one, let's see what we can do. So the question here is, can we divide the number of students n? So the question still is, here's the question that we have to answer is, the question is right here. This is the question we have to answer is the number of students divided by the number of classroom, does that yield an integer? In other words, is the total number of students evenly divisible by m, given the fact that we are told that 3 times the number of students now, not 13 times, but this time we are told that 3 times the number of students is divisible by m. Let's see what we can do. All we have to do here is to make up some scenario, and as long as we can find a contradiction, then we are done. Question is this: is m over n an integer? If in one case we find the answer to be yes, in one case if we find the answer to be affirmative, and in some other scenario if you find the answer to be negative, we are done. Second statement is not sufficient. That's what it is. Or rather, the first statement is not sufficient. So let's make up 2 scenarios. In one case, in scenario 1, and here is your scenario 2. Now, is n divisible by m? To answer that question, we're going to actually start out making sure that it is divisible. For example, let n be 60 and let m be 6. As we can clearly see here, that n is divisible by m. But let's see what happens when we have 3n. So here 3n would be 3 times 60, which is 180, and 180 is clearly divisible by 6. It gives us an integer. And it is also true, if that were, the way they phrase it, what they said is that if that were true, if 3 times the number of students, is divisible evenly by the number of classroom, in that case the question was, is n divisible by m? Obviously it is, because n is 60 and m is 6 in here, so it is integer. So in this case the answer is yes. The answer is yes. It's a very simple thing. Now we'll look at another scenario where we'll start out with something else. Something else, making sure to ask ourselves, would that be possible for n to be 100? So here we are starting out by forcing it. Here we are starting out by a scenario where we know the answer would be no if everything works out. So here 3 times n again is going to be 300, and of course 300 divided by 6, 3n. In other words, 3n divided by 6 is an integer, but here, as we can see, n divided by n is not an integer. It is not an integer because n here is 100, and one cannot divide 100 evenly into 6. So here, again one more time, the question is n evenly divisible by m, given the fact that 3 times n is divisible by m, to which the answer is, well, it depends on what n is. If n happens to be something like 100, then yes, it is true that 3 times n is divisible by m, but n itself is not divisible by n. The answer here is no. On the other hand, if you have something like this, the answer would be yes. Therefore, the first statement by itself does not do the job. Because the first statement by itself did not do the job, we find now that the answer is not D. I shouldn't have circled it. The answer is not D. Answer turns out to be B. Answer is B. Where can we put it? You see, this statement did not work. Second statement did work. So the answer is B. That's it. I hope you found this helpful. This was a tricky one. I hope you found it helpful. I will see you tomorrow, okay? Bye now.